Good day, my name is John Vincent S. Saracanlao. You can call me Sir John or Dr. Saracanlao. Our lesson for today is layouting procedure for a contingency table. A contingency table is not a response versus response analysis. It's frequency-based analysis. And as I've said in previous lessons, these are good statistical tools that you can use in terms of problems with normality and stuff. So we'll go through our analysis. So I have here is actually data from uh, a hospital during COVID when it first started, and it has a lot of information about client, respondent, and everything actually. But we're only calculating two intercepts between severity of COVID and death. So what we'll do now is to copy data and paste it to a new sheet. So we'll have this one. Okay. So we copied those with, I need to run you through this. I did the calculations a while ago. So just to make sure that everything is laid out. So we copied, wait, yeah, copied first is we copied the column, the severity and died, and we sorted from one to sorted alphabet from smallest to largest. So first is all one is mild one, moderate that's two, um, severe is three, and critical as four. So what we'll do now is copy the pair. So all those ones, we'll copy all the ones, the pair with ones with here. So Control C. Wait, that didn't go right. Undo. So we copy this one, all the ones, all the ones, all the ones here, ones, ones. So all those with mild, place it here, and the twos coded as two, which is moderate, and paste it two, two there. So those paired with two. No, wait, it's uh there. Two, all the two responses there. Let's see, paste it here. Those who have moderate and the intercept with that of recovery. And the tree, be the tree. Control C and paste it here. And the four, which is critical, and there. So place the four here. So what we'll do now is uh that we've copied everything, and actually what we'll do now is count the frequencies. So on the last line, we'll count the frequency. So we have here equals to frequency, open parenthesis, just highlight from the bottom to the top, and comma, and Ben, that's our Ben, uh, F4 to lock it, and close parenthesis, Control Shift Enter. So since we've locked our bin, you can just copy the results here. Sorry, we'll just copy our results here. So what we have now is actually the our contingency table, which is we'll make our contingency table here. So we have I already added a percentage so that we can also do simple descriptive analysis for this one. So we have there. No, I need to make it lower. Make it a little bit smaller so I have a clear view of everything. Hmm. There, one picture of that. So from that, we have now our contingency table. I just added the percentages so that we can do descriptive analysis. So we have for the mild, we have 60 who recovered and one died, and that's 98.36% recovery. And for mild COVID, you have 1.64 deaths. And for moderate, we have the same data here. So we have 92 recovered, two died, and for severe, we have 30 recoveries and 19 died, which is 38.78%. For those who are critical, we have four recoveries and 20 deaths. So from that alone, you can really have a good picture of what's going on. So you'll see that there are really number of deaths when you reach a critical level when you have COVID. And but if you are mild, then the probability of you dying or a probability of the client died is around 1.54%. Those are real data from when COVID started, just from a client that I made an analysis with. So from that, we can do descriptive analysis. From a contingency table, we can do analysis that are real. They are not theoretical, let's say probabilities and stuff. There are probabilities in a sense, but no p-values. That's what I mean. There's no p-values. Uh, in a different perspective, like the t-test and the f-test and the regression and the correlation. This is more specific because these are the data, and though the data may vary from one country to another, one region to another, this is the data within a public hospital. So it gives us a clearer picture of what's going on. So now we have data probability. So from that, death with COVID with mild symptoms, that's if you have mild symptoms, and the probability of death is over sum of 228, that's 0.43%. That's just less than 1% because we're not just looking at mild symptoms, but we're all looking at the total if you have mild, moderate, severe, or critical. And from that alone, we can here have a good picture of what's going on. Death of COVID with critical symptoms, it's 20 over 228, that's 87.8.77%. That's a lot. And if we have this data, we could have shown a clearer picture to the people on what's really going on in a specific region. And that for me would have been very beneficial to those who are watching or those who have access to the data to see, to lessen the anxiety or to have a calculated sense whether to be anxious or not, or to have a calculated real data sense of what's really going on other than just having been dominated by fear itself. But yes, that's one statistical tools that you can use. There's actually three statistical tools use. when you don't meet the conditions of normality from which you have to do in t-test, f-test, correlation, and regression analysis. So these are good analysis actually, and it can have a clear picture. It can have a clear picture. It can have a clear delivery. It can have clear information on what's going on. So yes, another is chi-square. So chi-square in Excel. So copy your contingency table. Then you have to calculate your expected values because these are observed values. Now we need to calculate our expected values. So sum of frequency, expected frequency is equal to sum of columns. That's the sum of columns. You have to lock it multiplied to the sum of rows. You don't have to lock the sum of rows over the sum of all, which is 228, and you have to lock it. You have to press the dollar sign and enter so that you will have just copy paste from here going down. You know it's correct when the total of expected values from observed and expected values are the same. And you go on to the next column. So equals to sum of columns multiplied to the rows over total sum of rows and total, and you go on and so forth until you finish your expected values. You know your expected values. You know the data are correct when the sum of your expected values per column and row are the same with the sum with the observed frequencies. And now we'll have to calculate our chi-square. So first is we will copy paste our observed versus the expected. This is our observed, 60 and 1, and our expected is 90, 49.76 and 11.23. Then you go on, copy and copy and copy by pair, observed versus expected, observed expected. Then you calculate your observed minus expected. This is your observed minus expected. That's H2 minus I2. Then you continue to do that until everything is completed. Then you have the square of your observed minus expected. So you just multiply that by 2 or uh, square it. Then you have your chi-square, which is chi-square is the square of observed minus expected over expected values. So that's your K2 over I2. Then copy paste the result, and our chi-square, our final chi-square is the sum of the observed minus expected squared over expected, so the sum. To calculate for critical values, you just simply type in CHI and V, open parenthesis, level of significance, and degrees of freedom. So our degrees of freedom is number of columns minus 1 times the number of rows minus 1. So we have 4 columns minus 1 and 2 columns minus 1. So our degrees of freedom is 3. And it will automatically count our critical value. So chi-square is 108.87. Our chi-square critical is 7.81. So these are the conditions. So reject the null if the after calculation if the chi-square is greater than the critical value. Accept the null if the after calculation computation the chi-square is lower than the critical value. Hypothesis is there is significant difference between expected value and observed value. And our null is there's no significant difference between expected and observed. Since chi-square 108.83 is greater than our critical value, then we reject the null. So we reject the null. So reject this null. That means we accept the hypothesis. So there is a significant difference between observed, expected, and observed data. This means that once there is a significant difference between the observed and expected, and the outcome is not based on chance alone, there is a factor that influences the data. The factor does not necessarily come from the calculated variables. The factor can be inferred from triggers that resulted to the data, to the or the data not to be based on chance alone, but by certain environment or circumstances. In this case, the observed and expected, there's a significant difference from the observed and expected. That means that there's a trigger from which the data are formed. What could that be? You have to infer. One inference, valid inference, is that the COVID, the deaths and the recoveries from the COVID, is not by chance alone. There's something going on there, and that could be a recommendation of the basis for recommendation for caution on not to treat COVID as something that is by chance alone, or not to treat it like a common flu from which the data between the intercepts between type of severity and death and recovery doesn't exist by chance alone. It is something bigger than by chance alone. I hope you understand what I'm talking about. To give you a concrete example, this is a pre-test intervention and post-test and post-test pre-test intervention, pre-test, post-test, pre-test intervention and post-test scenario. The result of the pre-test and the post-test should indicate that there is no significant difference between observed and expected in the absence of intervention. So if there's no intervention, there should be no difference between the observed and expected from pre-test and post-test. The data set of the pre-test may vary from the post-test by chance alone, but not significant. An effective intervention or experimentation will create a data set of the post-test to vary in the data set of post-test, not by chance alone, meaning the significant, meaning there is something that something happened to the data for it not to happen by chance alone. That means that there was an effective intervention or effective experimentation that made those changes for it to not happen by chance alone, but something that is influencing the result. Remember that the data set, the inferences are not included in the data set. It can be inferred. It can be a good explanation, and you have to have a critical mind to understand what are the conditions, what are the influences that created the data for not to happen by chance alone. Compared to other, remember that every statistical use has a purpose and has a conditions from its use. We have t-test, we have the t-test, we have correlation, we have regression. Each of them has a specific functionality from which you use. So one of which is chi-square, and we have correlation that tests the relationships. We have regression that predicts the expected dependent variable. We have t-test and f-test that calculates the difference between two variables. So all of these statistical tools can be used and should be used in a way that you are aware that I'm supposed to use this, I'm supposed to use that, I'm supposed to, and you have to also aware of the conditions that have to be met in order to use the statistical tool. So yes, that's a lot of things. That's a lot of pages to think about. However, I hope that this book really help you to lessen your fears or anxiety about research statistics. It's not that difficult per se. You just have to understand or read my book, or you have to understand the conditions and the processes and the relationships between concepts. And yes, that's the end of the lesson. I just submitted the book for final publication. I just approved it, and it hopefully it will be published before the end of the celebration of the Lunar New Year 2024. As I've said, you can always reach me. We just need to find a platform from which we can connect and we can help each other. I can help you in a sense. I'm really hoping that you will buy this book and really hoping that this book will help you survive the subject research statistics, but at the same time value its contribution and to continue data analysis in your own environment or work environment so that you will have effective recommendations, effective findings to the people within your company or your institution that you belong, and that will create uh, valid conclusions or just fair recommendations, not just random recommendations that is not based on any statistical data. So once again, I would like to end this lesson with a thank you, and I have said everything already. So thank you and have a great day.